There we go. So, thank you, Peter, for this introduction on the IEA. So, what is the big organization behind, I have to say. From my perspective as the chairman of the EBC program, so as we learned, this is one out of 40 technology-oriented programs. I'm going to speak to you today, and more concrete, I want to give you a feeling about what is an implementing agreement or what is such a research program. So EBC is the Implementing Agreement on Energy in Buildings and Communities. It is an international collaborative agreement, formerly known as ECBCS, so maybe some of you know this name. We are now only EBC, so we shortened the name, and we focused on our stakes basically. What are we doing? We are running a program on energy research and innovation, on development and demonstration, as well as on dissemination. And we follow an open innovation approach. So this means we try to gain some new knowledge, we produce results, and these results, they should be shared with other interested audience. Right now, there are 26 member countries in the EBC program. We established 66 annexes and 3 working groups over our lifetime, so this is almost 40 years right now. And right now, at the moment, we have 14 annexes ongoing. So I have to say, maybe an annex is international research, let's say, project, big project. And 14 of these are ongoing, whereas 2 are under preparation. You can imagine when I talk on one annex, usually you have around 15 countries that are contributing scientific work, so around 40 or 50 experts that are working for one annex only. What you see here is the list of the 26 participating countries. There are, most of them are members to the IEA. We have as well non-member countries. Well, there's only one right now. It is People's Republic of China. To give you a feeling how we do work and how we do govern our program, we do have a executive committee where each of the 26 countries that are member has a representative. So those 26 representatives, they make strategic decisions, they give guidance to the annex, to the projects, and well, this is where the decisions were taken. At the site, we established very shortly. We established three subcommittees. One is on quality assurance, with 4 people in it. One is on communication and technology transfer, with 7 persons, and one is on finance. This is 2 persons. So this becomes necessary as we are growing in, well, not only in countries but as well in annexes, and to keep it manageable, we established those subcommittees that give input to the executive committee. There is a secretariat in place, technical secretariat, responsible for internet, etc., technology transfer actions, and of course here are, well, this box is where the work is really done. This is the research project. the management, where the management, there is one operating agent is managing one of these annexes. So what you will, we're going to have a couple of presentations afterwards from 4 persons that are operating agents that are in that function. Well, I come to the problem statement, and we already heard from Peter Cunz. There are tremendous challenges in front of us. Climate change is driven by demographic growth and increasing GDP worldwide. Well, that leads to more consumption of energy, of fossil fuels, but as well of other resources like minerals. So there's a scarcity of natural resources. And on the other hand, there is policy that tries to manage those problems. But we have to state right now there's only weak policy measures and a very slow implementation by the world's leading economies due to different political views. So this highlights again a point that Peter mentioned. It's important to have common political views or to work on these as well. What we do is within the EBC program is not to work on this, but to work on the technical basis. But let me continue a little bit with the problem statement to show you our motivation more. So as we face climate change, one solution is the renewable energies, and on this slide you have not only renewable energies but as well other energies, and what you see is the energy return on invest on this energy. So when you start with old conventional oil, there was only the very small part here in red of energy investment for a huge yield. Later, new conventional oil already a factor 25 to 1. Well, that's still a small portion. You have to invest in energy for have this big output of energy on the other hand. Now when it comes to mineral tar sands, it's already 20% that needs to be invested for gaining 80% of energy, and this goes up to 1/3 of investment for in situ tar sands. And when it comes to biodiesel from soybeans or even ethanol from corn, you can see it's almost it's a huge investment in energy for gaining less and less yield. So what I want to say with that slide is that there are energies available, but you always have to pay for it. You have to invest for it in terms of energy. And there are differences. In particular, this is true as well for the renewables, for some of the renewable energies. Let's have a look on the mineral reserves. The reserves of the most critical metals, based on today's exploitation rates, are amazingly low. I'm not sure if you're aware, but when we continue like this, gold reserves are there only for 17 years, where silver is about 13 years, copper 30 years, and zinc, lead, palladium in the same range. The iron goes up to 50 years. And you have to keep in mind that we do not only run out of these minerals, but that exploitation becomes more and more energy intensive as the reserves become less concentrated, are more difficult to access, etc., etc. So this is another issue. Why do I show you this slide? You can see it in that example. where you see the steel intensity of power technologies, for example. Starting with a low intensity for hydro, for gas power plants, for nuclear, coal-fired, and it is growing when it comes to renewable energy production. For wind and for solar, you have quite a high steel intensity. So what I want to say is, as well here, you have to pay. You have to pay in energy, you have to pay in steel. These are all resources that we don't have for free. So potentially we run in a problem when we only focus on these options. On the other hand, and this leads me to our mission, on the other hand, the investment for energy efficiency measures are usually below this for renewable energy productions, and this is what leads us to our mission that you can see right here, and this is stated in our strategic plan. It is to accelerate the transformation of the built environment towards more energy efficient and sustainable buildings and communities. And this should be reached by the development and dissemination of knowledge and technologies through international collaborative research and innovation. So, to make a long story short, energy efficiency is key. That's what we are focusing on. Our research program is focusing on R&D projects, on knowledge deployment and demonstration, and we are developing R&D strategies as well, where the field of work is in the buildings field and the communities field. As well, this was mentioned by Peter Cunz. You can see the buildings and community sector is an important one in terms of energy consumption, CO2 emissions production, solid waste production. This is all around 40%, 30%. Primary resources are consumed up to 50%, whereas the GDP is touched by 10 to 15%. These numbers, they account for OECD countries. All in all, it's a very fragmented sector that does not make it easy for dissemination, as you may know. So it's a challenge. What is the challenge? The challenge is that there is a long value chain in this construction market. We do produce R&D output. You can see here at the left. We produce R&D output, so R&D results, either in the field of decision making and design or directly into building products and systems. However, they have to go through the whole value chain before they really produce an outcome at the end of the value chain, which is the facility operation and maintenance and management of buildings and the built environment as a whole. It's a long way, so we need to be aware of this. We have to go through all this long way. It does not stop when we produce our results, when we publish our reports. There is tremendous work to be done, that this knowledge goes through the value chain, that it flows into the market. In terms of technology readiness levels that some of you may be familiar with, we focus on quite a good spectrum, starting from TRL 3 and going until TRL 7. So this means what we are doing is very applied research. We're starting directly with analytical and experimental critical function or characteristic proof of concept. So the proof of concept level, we go through all these steps over validation, over let's say the prototyping, etc., until demonstrating and full-scale demonstration of the systems. In our strategic plan, we have defined 5 priority themes, what you can see here. These are Theme 1, integrated planning and building design. It's an important one. It's a complex one. We, of course, tackle still building energy systems, not very new, but still a lot of work to be done. Same for the building envelope. The community scale methods is an issue that comes more and more. In particular, there is as well a link to the smart cities and the Smart Cities Initiative from the European Commission. And theme number 5 is a quite new one, real building energy use, where we want to better understand the consumer, the user behavior, and as well to cover this in simulation. More concrete, we do have several projects in those fields already. In the first target area, integrated planning and building design, and there are 4 annexes running. Annex 61 is on development and demonstration of financial and technical concepts for deep energy retrofits. So this is focusing mainly on large buildings, on governmental buildings, etc. Then there is the second one, cost-effective energy and CO2 optimization in building renovation, where the approach is to do both, to do energy efficiency measures and CO2 optimization measures. So let's say this is basically use of renewable energies, and to optimize this in a way of investment and gain. It's upon developing a new methodology for this. Third, Annex 55 is on reliability of energy efficient building retrofitting. It is about probability assessment of performance and of cost, which is very important for appropriate planning, financial planning. And then we have towered net zero energy solar buildings, Annex 52. This is well, basically work is done there. There are publications available. It is as well working a lot on the methodology. What is a net zero energy building? What are the possible ways towards such a building? Theme number 2 is on building energy systems. We have an annex called ventilative cooling, Annex 62. This is more and more an issue as cooling comes as well for buildings, well, let's say for single family homes, etc., for small buildings, and they may have ventilation, and with this ventilation a lot of possibilities for cooling do exist if they are used appropriate without active cooling. There is Annex 60 on new generation computational tools for building and community energy systems based on Modelica. So Modelica is an open source software which is very much in the sense of our EBC program. Then we have Annex 59 on high temperature cooling and low temperature heating in buildings, how to do it correctly, where are the where do you have the potentials, etc. So these are questions that are tackled there. And Annex 54 on integration of microgeneration and other energy technologies in buildings. Annex 5, you may notice, this is not a typo, that's correct. Annex 5, it's a very old one, is the Air Infiltration and Ventilation Center, AIVC, and you're going to have a presentation on this later on. When it comes to building envelope, we have 2 annexes. 65 is quite a new one on long-term performance of super installation in buildings and components and systems. Danielle is speaking on these projects later on as well. And we have reliable building energy performance characterization based on full-scale dynamic measurements, Annex 58 as well. This is represented. Community scale, we have 2 new projects, 2 new annexes focusing on community scale methods. One is on low exergy. So this is more the technology approach, I would say, whereas the other is on implementation of energy strategies in communities, which means it's right at the top of our technology readiness levels. It is on implementation and strategies for implementation. So once the technical solution is there, still there is a problem to implement them into communities. And our theme number 5 on real building energy use. We have 3 running annexes: occupant behavior and simulation, evaluation of embodied energy and CO2 emissions for buildings and for construction, and 53 is total energy use in buildings, analysis and evaluation methods. Now I'm close to conclusions. So what I wanted to say is that the project results are available in either full scientific reports or only summary reports targeted for policymakers. We do produce fact sheets. Sometimes it's a handbook or tools. So these are possible results, and they are disseminated predominantly by our website, which you can see here. As well, we do provide a newsletter twice a year. We have an annual report, and of course conferences, seminars, information, etc. is provided via this homepage. Just to give you an idea of downloads, official annex reports, we were in the range of 2 to 2.5 million per year of downloads. So these reports, they are really downloaded and studied. So there's a huge interest in these results. And whereas, for example, the newsletter, it's around 150, 170,000 that are downloaded of every newsletter. No, per year, I'm sorry. Well, that's it. I hope this was a bunch of information what is useful for you, and I pass over to the next speaker.